Thunderstorms and snow typically don't go together, but thundersnow occurs more frequently than you might think, and this winter it's happened in some populated places, including parts of Pennsylvania. Let's go back to the evening of January 26th and follow the progress of the lightning strikes that accompanied the last big East Coast snowstorm as it moved from the Washington, D.C. area to Philadelphia towards New York City, along the way jolting snowbound residents of Pennsylvania from York and Lancaster counties to Bucks County with rumbles of thunder. A week later, the Weather Channel's Jim Cantore got his own surprise in Chicago while covering the blizzard that hit the Midwest on February 1st.
Oh my goodness! Holy smoke!
Now, thunderstorms with snow are usually built differently than typical thunderstorms, which tend to be tall, perhaps rising above 40,000 feet, and contain fast-rising, warm, moist air that originates near the surface. In contrast, most snowstorms feature layered clouds, maybe half that depth, with relatively gentle upward motions. In most thundersnow events, these develop bumps or towers that rise an additional few thousand feet, and this requires a strong mid-level lifting mechanism, usually an approaching trough, which destabilizes the mid-levels of the atmosphere, leading to what's called elevated convection, implying that the strong upward motions don't originate near the surface. It's kind of instability with a jacket on. If the temperature in this mid-level layer ranges from about -5 to 15, both snowflakes and small hail can form. And when these different particles collide, electrical charge builds up in the cloud, and eventually sparks may fly in the form of lightning. University of Missouri researchers have compiled a climatology of thundersnow using 30 years of observations. They found reports from the Great Basin across the central Rockies and Plains to the upper Midwest, around the Great Lakes, and in parts of the Northeast Corridor. The area of maximum reports centered on Utah is likely due to the mountains, with some enhancement from the Great Salt Lake. And speaking of lake effect, a more recent study using the National Lightning Detection Network found that areas just east of Lakes Erie and Ontario are a hotbed for thundersnow, averaging about 7 days a year. In fact, here's lightning strikes during a lake effect snowstorm near Buffalo back in the first week of December, an event that dumped nearly 40 inches just southeast of the city. Unlike other thundersnow events, those associated with lake effect are more like typical thunderstorms in that they derive some energy from low-level heating, in this case, the relatively warm lake waters. Now, in most cases, thundersnow is associated with heavy bursts that can accumulate quickly on the order of a few inches per hour. Much like warm season thunderstorms often bring downpours that can soak you in a matter of minutes. Paul Knight is back with the extended forecast next.